All right, so I want to go through a quick review for our test tomorrow. So it's been a while. I mean, really, yesterday we kind of was a catch-up day a little bit, kind of get up to steam, get some work done. So this is the first day back after a good solid week off, right? So it's been a while. So we got to refresh our memories on this. 3 topics on the test tomorrow. This is not a hard test. I think this is one where you could, pretty easy to probably master this stuff and have this be a great booster. Okay. 3 topics: factoring, completing the square, and the discriminant. I'm going to start with the discriminant by special request, and we'll kind of work backwards from there. So let's remind ourselves about the discriminant, right? The discriminant just is based on the quadratic formula. So let's do a very brief review of the quadratic formula. So with the quadratic formula, there's really 2 parts to it. There's the formula itself, but there's also the form the equation has to be in order to use the quadratic equation. So if we've got a quadratic equation, what form does it have to be in order for us to use the quadratic formula to solve the equation? Standard form. Good. And what is standard form? What is that? A squared plus bx plus c equals, and this is important, what number? 0, right? Quadratic equation in standard form is always set equal to 0, okay? If that's true, if it's in standard form, then every time we can use the quadratic formula. The solutions are guaranteed to be x equals, I'm going to warm up your voices a little bit here maybe, but what is
negative b plus or minus square root b squared minus 4ac divided by 2a?
That's it, right? That's the formula that always gives us the answers. Now, we got a test tomorrow over those 3 topics I mentioned. Here's how the week's going to go. Thursday, we're going to spend a day doing really nothing new. All we're going to do on Thursday is we're going to talk strategy. We're going to talk about if I give you a quadratic equation, your job is going to be to pick what's the best method to solve it. The next test, the 3rd test, we've already done 1 test a while ago from Unit 2. We're doing test 2 from Unit 2 tomorrow. The 3rd test, which we'll do, maybe like Monday or Tuesday next week, all it's going to be a series of problems that are multiple choice problems where I give you a quadratic equation and you've got to pick from the list of choices, you've got to pick the best way to solve that quadratic equation. Okay? Is it quadratic formula, or is it completing the square, or is it, and there's going to be some criteria that we'll spend Thursday talking about that determines which one you pick. It's not hard, right? We just get strategic, and it's time for us to start being strategic about math at this level. The other half of the test will just be solving some quadratic equations using, at that point, hopefully using the best one, but just getting correct solutions, right, no matter what. Okay, so here's our quadratic formula, right? What part of the quadratic formula is going to determine if we have real or imaginary solutions?
b squared minus 4ac.
Yeah, right. The part under the radical. Everybody agree? So it's this part right there. That's the part to discriminate means to separate. So that's the part of the formula that separates the imaginary solutions from the real solutions, right? You remember talking about this hopefully. And we said, we made a couple correlations here then, right? We said that if the discriminant that's pretty tricky, huh? If the discriminant is positive, so it's greater than 0, what's that tell you? What's the quadratic formula guaranteed to give you? It's positive. No. 2, what kind? Real. Not going to get any i's, right? I'm going to get 2, 1 for the plus and 1 for the minus. So I get 2 real solutions. What if the discriminant is less than 0, so it's negative?
2 imaginary.
I'm getting imaginaries, aren't I? If I have a square root of a negative number, that always means I, right? I'm getting i's in my answer, and I'm getting 2 of them, 1 for the plus and 1 for the minus. And then in the middle, Yeah, if the discriminant equals 0, I'm getting negative b plus the square root of 0, which is just 0, right? So negative b plus 0 or negative b minus 0 on the top. Well, that's the same thing. It's just negative b, right? So I'm only getting back one real solution. So all this section is asking us to do, very little. You don't have to do much at all. All you have to do is just determine, is the discriminant going to be positive, negative, or 0? And really, once you know which of those three things it is, the other part of the question is already answered, right? If it's positive, it's 2 reals. If it's negative, it's 2 imaginary. If it's 0, it's 1 real. That part's a slam dunk, okay? So let's look at this one. Is it in standard form to start with?
Yes.
It is. So then if it's in standard form, all we have to do is just evaluate the sign of the discriminant, positive or negative. So we're looking at b squared minus 4ac, the part under the square root. What's b squared going to be?
16.
Right? Because b is just negative 4. Everybody agree? A is 3, b is negative 4, and c is 4. So I'm going to get 16 minus 4 times what? 3 times 4. Okay, what is the sign of, I don't have to even know what the number is, but what's the sign of the number going to be?
Negative.
Gotta be negative. I got 16 minus a big number, right? Is going to make it negative, agreed? So I get negative there. 2 imaginary solutions. Boom, done. Okay, what about that guy? What do I have to do first?
X root.
Gotta move the x squared right to the other side. I gotta get it equal to 0. So first, to put it in standard form, if I add x squared to both sides, everybody agree? I'm gonna get 4x squared minus 16x plus 16 equals 0. Okay? So I could use the values of a, b, and c for negative 16 and 16. And it would work, right? But let's think about this. Can we make our lives easier, right? If you were doing, I want you to draw a parallel here to something else that you would do very naturally. What if you were solving the equation, say we had 4x squared equals 16? What would you do first?
Or divide by 4.
You divide both sides by 4 to make it simpler, to get x squared equals 4, right? And then it's easy. Agreed? Okay, is there something that would divide evenly into both sides here? Well, I mean, 0, you can divide 0 by anything. Is there something that I could divide this side by conveniently? 4, yeah, right? Now, think about this in terms of a greatest common factor. What's the greatest common factor of the left side? 4, yeah. But instead of factoring it out, if we're trying to solve an equation, why not just divide both sides by 4 to make it easier? Right, you see my point? Okay, so if I divide each side through by 4, look what we get. Dividing dividing by a common denominator 4 means I'm just dividing each term separately by 4, doesn't it? Right, so what's 4x squared over 4? Good, what's negative 16x over 4?
4x.
What's 16 over 4?
4.
0 divided by anything is 0. Easier, right? Now what's a, b, and c? 1, negative 4, 4, right? So the discriminant then, b squared minus 4ac is going to be 16 minus
4
times 1 times,
4.
what's that?
0, so there's 1.
Right? No biggie. Okay, last one. Looks scary, but it's not. We're not scared of a bunch of fractions. What do we do if we have a bunch of terms that have fractions? Okay, what are we going to do? Greatest common factor? Or, okay, least common multiple. Greatest common, right, does that make sense? Yeah. Least common multiple. The common denominator of the denominators, right? What would, in other words, what's the smallest number that all those divide into? Now, you're getting a common denominator here, right? What would my common denominator be if my denominators are 4, 8, 4, and 8? No, not 4. 8 doesn't divide into 4. 8, right? Wouldn't I just multiply this one by 2 over 2 and that one by 2 over 2 to get 8's on the bottom? Everybody agree? Okay, so that's called the least common multiple, the smallest thing that they divide into. Okay, so I'm going to multiply both sides through by 8 to clear the fractions. So instead of multiplying straight across and reducing big numbers, I mean, I could. 8 times 3 is, that's really just an 8 over 1, right? 8 times 3 is 24 over 6 is, over 4 is what? Whoops, gave it away. 6. But we'll do it a better way, right? We know that if we're clearing fractions, I can always reduce first. 8 over 4 reduces to 2 times the top. There's my 6, right? 6x squared, 8 over 8 is 1 times the top. Negative 9x, 8 over 4 is 2 times the top. 8 over 8 is...
That would be negative 10.
Oh, whoops, you're right. I did. Two times negative 5 is negative 10, good. And then 8 over 8 is 1 times the top. There's my 3x squared. Am I done?
You gotta move this.
Good. Got to move 3x squared to the left, so I'll subtract 3x squared from both sides. And so that's going to give me 3x squared minus 9x minus 10 equals 0, right? Okay, now what's A?
3,
B?
negative 9,
C?
negative 10.
Okay,
So.
so I'm going to get 81, right? B squared is always positive, right? Okay, always, because square or negative number is still positive. Minus 4 times 3 times negative 10 without even thinking about it. What's the sign? How come?
Because the negatives cancel out.
Negative times negative is positive, right? I'm subtracting a negative. So I don't even have to worry about it. I know it's positive. So that tells me if that's positive, I get 2 reals, right? No big. Okay, so that's the discriminant stuff. Okay. Let's go back to the factoring stuff. Let's start with a normal one, something like that. So let's just kind of review quickly the factoring. Okay, right? Maybe it's been a while. So factoring, let's remind ourselves what factoring even means by just factoring a number. If I want to factor the number 30, let's just use a factoring tree. What are 2 factors of 30?
15 and 2.
15 and 2, okay. 2's prime. What about this?
5 and 3.
So those are all prime, so that's just equal to 2 times 3 times 5, right? If it's completely factored or fully factored, it means I can't break it apart anymore, which I can't. Those are all prime numbers. What happens if I multiply 2 times 3 times 5? What do I get? 30. That's the way factoring works. It's the opposite process of multiplying, right? They're just inverses of each other, okay? So my goal here then is when I factor something, remember, and I know we've talked about this a bunch, but I gotta review this maybe. X squared plus 2x minus 80. My goal is to see if I can break that apart into a product of smaller pieces. Now maybe I can, maybe I can't. But if I can, let's think strategy here. What's the value of A in this expression? 1, right? So when A equals 1, that's good, right? That makes life easy when we're factoring. If A is equal to 1, if it factors, I know that what would have to go there and there?
X and X.
X. It has to, right? Because when I multiply this out to get this back, the only way I'm going to get an x squared is if I distribute the x to the x, right? So if it's going to factor, remember, those have to be x's. The question is just, do we have the right, are there numbers that are going to work? Okay, what would the numbers have to do in order to multiply to give me this? What would the numbers have to do? Multiply to negative 80
And then add to.
and add to positive 2, right? So if you have trouble with those, and you just get better at this, the more of this you do, the better you get at factoring. It's just a skill like anything else. Let's play the sign game though. Just sometimes that might be helpful. If the numbers multiply to a negative, what's that tell you? But just the fact they multiply to a negative tells me I get opposite signs, one negative and one positive, right? Aaron, if they're adding to a positive, which one must be bigger? The positive. So we'll put the bigger one first, and I know it's got to be like that. Now, what two numbers fit the builder? Yeah, 10 and 8, good. Or, yeah, 10 and 8. So it did break apart, so it's factored. How could I check this on a test? There's a built-in way to check this. What would I do? Multiply it out. What would I have to get if I multiplied it out?
Can't be even.
That, right? Okay. What about that one? So if it factors, it's got to look like that, right? Because A is equal to 1. The numbers have to multiply to what?
9.
And add to,
1.
what numbers are those?
Negative.
Signs would have to both be positive, wouldn't they?
See if we would.
Are there numbers that do that?
Or
No.
factor.
No problem.
Yeah, there are no numbers that do that. So this one is, it's already as small as it'll go. You can't break that apart. It's factored. Okay. Okay, what about something like that? That's much easier, but it's different, right? Now, this is a binomial. These other examples were trinomials. They had 3 terms. Trinomials require magic numbers, right? Binomials do not. Binomials are easy. All we have to do with a binomial is see if I can factor out a greatest common factor, and that's it. So let's think about that. What is the greatest common factor?
Negative 4x.
Okay, so there's a number part and then a variable part, right? The number part, the biggest number that goes into 8 and 12 is 4, but the leading term, right? The term that has the biggest power of x is negative. So I'm going to take the negative out in front, right? So we can undistribute a negative 4, and then for the variables, right, I can only undistribute what the weakest power of x is, right? Each term is only going to have so much x to give me, and so the power of x that's included in the greatest common factor is going to be the smallest, the weakest power of x from all of the different terms. Well, we've got an x squared and an x to the 1, so I can only take an x to the 1, right? So that's my GCF. And then now we just need to know what's left behind when I factor that out. Okay, well, there's a couple ways to think about this. Let's just remind ourselves. We could kind of reverse the distribution process and fill in the blank. Negative 4x times blank equals negative 8x squared.
Negative.
No.
Positive.
Oh, you're right. No, hang on. Not negative. Negative 4x times what equals negative 8x squared? 2x, okay? Here's another way to do that, though. You could always just say if I divide this term, the first term, by my GCF of negative 4x, what do I get? X squared over x, we know that gives us x, right? And negative 8 over negative 4 is 2, okay? How about this guy? If I divide 12x by negative 4x, what do we get?
Negative 2.
And the x's cancel. Negative 12 over negative 4 is negative 3, so we're done. No big deal. Okay, how would I check it? What do you mean? Multiply it out, yeah. And I see if I get that back, right? Okay, what about something like that? And let me preface this by saying, Thursday, we're gonna talk strategy. Thursday, when we see a problem like this and we're picking the best strategy, factoring is not gonna be the right choice. It's hard, right? A is not equal to 1 here. So we're stuck doing a harder factoring process. We would just move on, probably do the quadratic formula, right? But just like in athletics, we overtrain, right? We train hard in practice so the games are easy, right? So we'll hit this one. What do we always want to try to do first? Greatest common factor.
None.
There isn't one this time, though, isn't there? Right? So we're stuck with that the way it is. Remember what our rule is. If A is not equal to 1, right, then bottoms up. gonna use it to solve quadratic equations really, but it's one of those things that's just, you're expected to know. When you go to college and take a Math 105 class, or go on to college algebra here at high school next year or something, they're gonna expect that you know how to do this, so I'll make sure you do. So bottoms up. Remember, when we're doing, it's supposed to be a 1. The first step in bottoms up is we're gonna write our preliminary factors, right? So we're gonna make it look just like we normally would, right? But the magic numbers are a little different. How do we calculate magic numbers? What are the values of A, B, and C here first?
15, 17, 4.
Okay, so what do the magic numbers have to multiply here to? 4. Remember in bottoms up? A times C, good. So A times C
60.
equals 60. What do they have to add to? That's what they're gonna multiply to. What do they have to add to? B. Yep. B equals 17, so they have to add 17, right? And then we just gotta go find those numbers. What are the signs gonna be if they multiply to a positive and add to a positive? Okay, positive, good. And then I just gotta go find numbers that, where it works. Obviously, if I try something like 60 and 1, my result is way too big. If the numbers add to something too big, what do I need to look for the factors? What do I need to do? Instead of having them be real far apart, what do I have to do? I narrow the gap, right? The closer they get together, the smaller the sum would be. So we could skip down. 1 goes into 60, 2 goes into 60, 3 goes into 60. Let's try 4, maybe that'll help. So 4 times 15, what's that add to? Okay, we're getting close, right? We just gotta get them a little bit closer, don't we?
5 to 12.
5 and 12. There's our winners, right? Magic numbers that multiply to 60, A times C, and add to B, 17. So plus 12 plus 5. But remember, bottoms up, that's clearly not the answer, because if I multiply those out, I'm not getting that, am I? Right? So what's the next part of bottoms up? Call it step 2. What do I have to do to those magic numbers? Divide by, I heard it. Divide by A, yep. I'm going to divide each one by A, right? And now the last part's simple. What do I do?
Simplify.
Reduce the fractions and then go bottoms up. And I'm done, right? So if we reduce the fractions, call that step 3. Reduce, I'm going to end up with x plus, what's 12/15 reduced to? 4/5. 3 goes into both of those, right? How about 5/15? Okay, and then the last step is bottoms up. If we need to, if I still have fractions after I reduce, I have to go bottoms up. If I don't, fine. So the 5 goes up front, the 3 goes up front, and so our answer is 5x plus 4 times 3x plus 1. And if I multiply that out, I should get that. It works. Okay? If you can do that, you can pretty much do anything, right? Last one, real quick. This one looks like it's going to be bottoms up. But what can I do first? Greatest common factor. What's that going to be?
-2.
Good, I got to make it negative. So I can take out a -2. What am I left with?
X squared.
Okay, so -2 times x squared is -2x squared. -2 times what is positive 14x?
-7.
Good, -7x, right? And then -2 times what is -20?
+10.
Oh, yeah.
Okay, and I could just divide each of those through by -2 to get those also, right? So am I done? Not quite, right? The -2 is out front, that's my constant factor, but can I break this apart? This is a trinomial where A is now equal to 1, right? So this is an easy one.
But,
Are there magic numbers?
Yeah.
We gotta multiply to
And
10, add to
negative.
-7. So if they multiply to a positive and add to a negative, the signs are
Negative.
negative. What numbers do the trick?
-5.
Done. Right? If I multiply all that out, I'm gonna get my original answer. Okay. All right, so last part, quick review of completing the square. Okay. I think this really helps to see this kind of like the third time on this. I think if you have any issues about it, today's the day that they get completely answered. Okay, so let's see, Skylar, where do I start? If I'm completing the square, what form do I have to, what's my starting point for completing the square? I gotta get x squared, remember this? Plus
Yeah.
bx. No.
Equals a number.
Okay, space equals a number, right? That's where we gotta get. If I can write the original equation in that form, I'm set to complete the square in one step. Okay? What do I have to do to this one to get it there? Add 4, right? So my starting line is right here. X squared minus 12x space equals 4, right? Now think what we're doing. This really works well when we're talking about factoring, because what we want to have happen on the left side is we want to have this factor into, so the magic numbers are going to be x plus the same number twice, which we can just write x, say it was x plus 7. X plus 7 times x plus 7 would be just x plus 7 squared. It's not 7. Right? But we want to have it work out that way. Okay? Well, we already know what that's going to be. If I want to ultimately add some number to both sides so that the magic numbers multiply to something and add to -12. Well, how can I get two numbers that add to -12 that are the same number? Divide by 2, right? You get that? So the first blank that we'll fill in is always going to be this one, right? Okay, now we're kind of working backwards, though. What number would have had to have been there? Now, we would have had to have picked a number that multiplied to something and added to -12, and the numbers were -6 and -6. Well, what did that number have to be? 36, right? It had to be whatever that number is squared, which is 36, right? Everybody see that? That works, doesn't it? Right? If that's a 36, so that's kind of the second step, right? Think about that. What numbers multiply to positive 36 and add to -12? -6 and -6. We did it, right? We built a trinomial that factors into a square, right? A perfect square. So we call that a perfect square trinomial. Well, if we add the 36 to the other side, then finally, what's the number on the other side?
40.
Yeah. So step 3, we get 40. And notice that that is our answer. That's what was being asked for the whole time. Right, just complete the square. Okay? What about one like this? Do you think after Thursday, we'll choose to complete the square on this one?
No.
How come? You're right. What's wrong with this one?
They're all prime numbers.
Well, it's not that. I can put this into the starting form pretty easily by just subtracting 3 from both sides and get x squared plus bx space equals a number. What's the problem with b, though?
It's
It's odd. So when I divide by 2, I get a fraction, right? Which is just a little bit inconvenient. So we probably wouldn't want to use completing the square here. We know that if I did, though, the magic numbers would have to be 7/2 and 7/2. So what number would have to go here? whatever that is, squared, right? So if I square a fraction, that's no big deal. I just square the top and square the bottom. What do I get? 49/4, good. And so all I've got to do is just add -3 plus 49/4. What's the trick? How do I add fractions? No. Fractions? How do I get to have fractions? Common denominator. Yeah, so I gotta multiply this one by what, top and bottom? Yeah. So what's that gonna give me? I'm gonna get -12/4 plus 49/4. What's that? Yeah, that's just gonna be -37/4, and I'm done, right? Agreed? Okay. Oh, positive, you're right, I was just checking, see if you're paying attention. No, I wouldn't, made a mistake. Right, does that make sense? Okay. And then this one we won't even do. What's the only thing I'd have to do maybe just to get this one started? It looks a little weird, but good. So add the x squared to the left side, right? So on the left side, I'm gonna get x squared plus 2x, and then add the 2 to the right side, space equals 2. And I'm set. Good? All right. Okay, you get 10 minutes. Work for 10 minutes. Get some questions answered. If you're done with everything, you know, maybe work on some practice problems from that practice test. There you go. Yeah, you bet. Yeah, you bet.